Okay, let's finish out 5-1, 5-2, 5-3 with some right triangle trigonometry. So go ahead and try these Pythagorean theorem questions. Here are the answers so you know what to look for. Just practice setting up a squared plus b squared equals c squared, where c is the hypotenuse's length. So Pythagorean theorem, we're given two sides and we want the third. But there might be some cases where we don't have that scenario, or we might not want that. So in comes the angle, right? And we want to be able to use this angle information to help us find more parts. So that's what the trig ratios do for us. And they're ratios of sides of a right triangle. And remember, our ratio can be any sort of fraction, like a part out of a whole, or, if I ate 2 slices of pie out of 8 slices, it's 2 out of 8, It's comparing the amount that I ate versus the amount that was there. And you can do the same to compare sides of triangles. So when we're at A, we call this the opposite side because, well, it's opposite A. And the hypotenuse, we know, is across from the right angle. And then the other one is called the adjacent side. Okay? And you'll be given these ratios, but sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, we simplify that with SOHCAHTOA, which kind of has all the first letters ready for you, and you've probably heard that before. So let's practice using these. So from the vantage point of G, we got sine of G, cosine of G, an angle, tangent G, where G is the angle again. So what you can do is you can set up fractions, right? Because sine is opposite over hypotenuse. So if we label our triangle, I always start with the opposite. It always makes sense to me. The opposite is 15, the hypotenuse is 17. So that's the setup. That sets you up a ratio that can help you find an angle or side. And cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's actually see this in action then. So if we have an angle, again, go ahead and label your 3 sides. And you're going to pick sine, cosine, or tangent to work with. And always look to see what you have. You have the opposite and you have the hypotenuse. Okay? So a good choice would be to use sine, where sine of an angle is opposite over hypotenuse. So the finished ratio is x over 9. And to solve for x, we're going to cross multiply. So we got 9 sine of 51 equals x. Because remember, this is how we cross multiply, with that equal sign in there. Okay? And our calculators are able to do this. You want to make sure your calculator is in degree mode, which I can help you with that if you ever have questions. But you can type this in. Your calculator is really good at finding the sine of an angle. So this, when you type it in, is going to round out to 7.0. Let's try setting that up one more time. So angles here, opposite is 8. Hypotenuse is the longest side, and this is adjacent. So now, if we want to set something up to solve, we got to use stuff we know. So we know the adjacent, we know the opposite. So we can set up tangent of 55 is opposite over adjacent. It's the only trig function that uses opposite and adjacent. Okay, so tangent 55 is 8 over x, and we're going to use that same strategy. We're going to cross multiply, which gets us this, And then it's a little awkward, but we're going to divide both sides by that tangent piece. Think of that as an object that we can just divide by. And if you toss it in your calculator, you'll get like maybe 1.3. It's a decimal. So we can, of course, divide both sides by a decimal. So the reason why is because it cancels there. And this would be the final answer, which we're going to want as a decimal rounded to the nearest tenth, which that's going to be 5.6 for us. So this leg right here is 5.6 units long. Okay. So we're utilizing the angle to help us find sides too. Okay. And then the final piece of this that I want you to know is you can actually find angles as well. We just found a side. You can find angles too. So let me show you. The start is the same. It wants angle x. So this is going to be opposite. This is hypotenuse and this is adjacent. Same exact strategy. Pick the ones you know. So I know that cosine of x is adjacent over hypotenuse. And those are the two sides I know. I don't know anything about opposite, so I'm not going to pick tangent or sine because they have to deal with opposite. So I'm strategically picking one. And then the adjacent is 15. The hypotenuse is 20. Okay. So we're at kind of a weird spot right here. You could say, oh, let's cross multiply. But there's no x like in the fraction that you could like solve for. The x is stuck in the cosine. So what I'm going to ask you is, how did we solve this? What did we do to solve this equation with Pythagorean theorem? We took a square root. So by taking the square root of both sides, what it does is this became just x and this was 6. So instead of like square rooting both sides, we got to figure out a way to undo cosine, not undo the square function. So that's what cosine inverse is made for. And your calculator knows how to do cosine inverse. So if you apply it to both sides in the same way that you'd apply a square root, this, just like this, is equal to x, angle x. Because inverses cancel each other. And the trig functions have pre-designed inverses that can allow us to solve for stuff that's stuck inside. So we can type this in the calculator. You're going to want to use the second button and hit cosine. Okay. And this is going to be 41.4 degrees if I type that in. Okay. So the inverse trig ratios are angle finding functions. And they are sine inverse, cosine inverse, and tangent inverse. Let's try this last question together. So we have an escalator and a subway, not an elevator, an escalator, which is basically a moving staircase. And we have that the length of that is over 1,000 feet long, and at the end of it, you're 195 feet up. So we kind of have this ramp forming. It's a right triangle. It wants to know what this angle of incline is, which we'll call x. Okay. So now you're going to go in and label. So if that small angle is our reference point, this is opposite it, right? See, that's way across the side. And this is hypotenuse. And this is adjacent. But I say adjacent like that because we don't have any information down there. The adjacent's kind of useless here. But we do have information about opposite and hypotenuse. So, and that's sine. And you'll be able to figure that out because you'll be given the definitions. So sine of x is 195 over 1,125. And we're going to use sine inverse to help us free x It is stuck in there. So you have to do stuff to both sides, as we always do. Okay? And at the end of the day, you're going to get x because the sine inverse cancels the sine. And then once you type this in the calculator, which is doable, it looks crazy, but the calculator can do it just fine, is 10 degrees. The nearest degree. So that escalator it's not steep, right? It goes up very gradually. It's also like over 3 football fields long, so it seems really, really large. I would like to see this escalator.